Hello, this is the film about scientific notation. Scientific notation is something we use when we're talking about really big or really small numbers. So I want to start by showing you a website, taking you to Scale of the Universe, and I'm taking you to the English version of it. And what I want you to notice is as we start this, notice the numbers down here and what happens as I change them, okay? I'm making things bigger right now, right? I'm getting larger and larger items here. And what's happening to that number? 10 to the exponent. That exponent's increasing, right? Okay. When numbers are getting bigger in scientific notation, our exponent is going to get larger and larger. You would not want to have to represent a number with a bunch of zeros after it, and I'll show you that in just a minute. But you can start to see how some of these numbers are getting really large and they have many, many zeros in them. When that happens, it makes it very hard to write a number, and it takes a lot of time. The opposite is also true. If I go back to my size of being 1, essentially 1 meter, okay, and I start getting smaller, I'm going to move my cursor the other way. You can see that what's happening is I'm getting negative numbers here, right? So I'm getting more and more negative as time goes on. These are getting smaller and smaller. You can see that as the numbers are written, these numbers are getting smaller with more zeros in front of them for the decimal parts. Okay, so when we talk about scientific notation, this is what we're going to be talking about, is another way to write these types of numbers. Okay, I'm going to get off of this website. If you'd like to go there, it's just Scale of the Universe is the Google search I did. So you could easily play with that website some more. I'm going to hook you up so that you can see my whiteboard now. And you can see I wrote down the site that you can find this information at. So I'd like you in your notebooks to label this section Scientific Notation. And basically, scientific notation is a way to represent really large or really small numbers. So if I want to represent a number with many zeros after it, those zeros can be a problem to represent. Maybe it's hard to see how many zeros there are. Maybe it's just a lot of work. So typically in this situation, what we do is we use scientific notation. It's used a lot in the sciences. The idea of scientific notation is you place the decimal so that it has one non-zero digit in front of it. Okay, so I'm going to show you an example of this in just 1 second here. Okay, so with this number, I would put my decimal right here, right after this 3, because then I have 1 digit in front of my decimal, okay? I put my number times 10, and this is going to be the same in every single scientific notation. This part, the times 10, is the same. And then to the exponent. So to find the exponent, what we're going to do is we're going to see how many places I need to move my decimal to be at the end of the number. So here, let's do this. 1, 2, 3, 4, 5, 6, 7, 8, 9. I moved my decimal point 9 places. Now notice I kept that a positive 9 because I started with a whole number. Okay, so if I'm starting with a number that's not a decimal number, that is bigger than 1, I'm going to want to have a positive exponent. Okay, let's try another one. Let's try this number. If I have 2,600, okay, I'm going to put my decimal so that there's 1 digit in front of it. So that's where I'm going to put my decimal for the scientific notation. So then I copy this first part, 2.6, and I put times 10. And in this case, how many places did I move my decimal to move it from the end of the number to here? I moved it 1, 2, 3, 3 places. So times 10 to the third power. Hopefully that's making sense. So the thing to remember is that when you're dealing with a number bigger than 1, your exponent is positive. If I'm dealing with a smaller number, let's say I have this number, 0.003, and I want to write this in scientific notation, my first step's going to be the same. I move my decimal. Okay. Here I'm going to move it behind the 3, right? I want 1 digit that's not 0 in front of the decimal. So I'm going to move it to here. So I'm going to move it from here to here. So how many places did I move it? 1, 2, 3. Okay. So then I counted the number of places that I moved it. Okay. In this case, I moved it 3 places. And then I need to decide if I should have a positive or a negative. So in this case, I started with a decimal number, right? I started with a number that was less than 1. So anytime I start with a decimal, if it's less than 1, it's going to have a negative exponent. If it's more than 1 or greater than 1, I'm going to have a positive exponent. So make sure that you get that in your notes, please. Okay. Now that I know what my exponent is going to be a negative in this case because my original number was less than 1. Now I can use my structure. So now my next step is put your new values in this equation. So we're going to do blank times 10 to the blank. Okay? So you're going to put some value here and some value here. In this case, my value here is going to be my 3 because that was the digit that I moved the decimal from. Decimal to the end of. Okay? So there's my 3. Times 10 will always stay the same. And now we're going to look at the exponent. I moved my decimal 1, 2, 3. So it's going to be my negative 3 because I started with a decimal. Okay. Let's try another one. I'll have you try these 2 right now. So for each of these, I'd like you to put them in scientific notation. You can pause the video while you do that. Okay, so this one, when we move our decimal point, we're going to move it between the 7 and the 4. So it's going to go in that location so that there's one non-zero digit in front of it. To move my decimal there from the end of the number, I have to go over 1, 2, 3, 4, 5, 6 spaces. So I'm going to have my exponent be a 6. Now, is that positive or negative? It is positive because I started with a number bigger than 1. For the second one, 0.01, if I move my decimal point so that there's one non-zero digit in front of it, I have the number 1. I can then do my times 10. And how many places did I move it? I moved it 2. And my 2 is going to be negative because I started with a decimal number. So you're going to get some more practice on this. You're going to get practice, first of all, in your supplemental packet. So if you look at pages 6 and 7 in your supplement, you'll get some practice with scientific notation. I do need to make one correction here for you. You'll notice the top directions say multiply or divide as indicated using powers of 10. What happened here is the division sign came out looking like a plus sign. So everywhere in this top section you see a plus, you're going to change it to division. Okay? So you can go ahead and work on page 6 and on page 7 here, and then you can check your answers online. I'll make sure the supplement is up for you. Also, you're going to be working on some textbook work from Wallace. So let me show you how you can access that. I'm going to come back to my computer here, and I'm going to get on the internet. So once you get to WAMAP, you can put your details in there. Okay, so on WAMAP, if you want to do your scientific notation homework, you're going to look in Wallace 5.3. Okay, it's under week 7, Wallace 5.3. And here is your scientific notation work for you to work on. So click there. It's going to bring up a page. And notice in your homework sheet that you're just doing the top 2 sections. Okay, so you already know how to do the scientific notation. I'm going to show you the reverse quickly here, doing the standard notation. So I'm going to go back to my board now. Okay, so now if we start with scientific notation and we need to go to standard notation, it's pretty much the opposite of what we just did. Okay, so if we started in standard, in scientific notation, so if I have 3.2 times 10 to the 5th power, okay, I'm going to look at it and see that my 5 is positive, right? So I know that my number is going to be bigger than 1. So if my number is going to be bigger than 1, I need to move my decimal point to the right here to make this number bigger. Okay, so how many places am I going to move it? 5. So move it 1, 2, 3, 4, 5. From here, I have to fill in these zeros. So I'm going to fill in a 0 here for each of these. Okay, so then I end up with this number here. If I put a comma in it there, I now have my standard notation from my scientific notation. The same thing can happen with decimals. So if I had 3.2 times 10 to the negative 2nd, what I'm going to do is I'm going to start by moving my decimal 2 places, and since it's negative, I'm going to move it so that it turns out to be a decimal number. and I come up with 0.032 as my answer there. Okay. So I'm going to have you do a little practice with scientific notation right now, with taking scientific notation to standard notation. So here we go. 7.8 times 10 to the third, and 6 times 10 to the negative fourth. So take a moment to do those. Okay, in this first case, if we move the decimal place 3 places, that's 1, 2, and 3. So we have 7,800 as our answer there. In the second case, we have a negative exponent, so I know I'm going to have a decimal, so I move the decimal place 4 places. You can see that I have to add some zeros there as my placeholder, so I get 0.0006 as my answer. Okay, so as I said, you have some practice on WAMAP, and you have some practice in your supplemental salmon-colored packet. So please take some time and work through those. Bring any questions on Monday. Thank you.